Artificial intelligence appears to exist entirely in software. When people interact with AI systems, they see a chatbot, an image generator, or a recommendation engine. It feels like intelligence is emerging from code. But behind every AI system lies something far more physical. A massive global infrastructure of machines. Warehouses filled with servers. Buildings consuming enormous amounts of electricity. Facilities designed to perform trillions of calculations every second. These are AI data centers, and they have quietly become some of the most important technological facilities in the modern world. Most people never see them. They sit in remote locations, often built far from major cities. But inside these buildings are machines that power modern artificial intelligence. To understand how artificial intelligence really works, we need to look inside these facilities. Because AI does not live in the cloud. The cloud is simply someone else's computer. And those computers are located inside data centers. A modern AI data center is a carefully engineered environment. Every component is designed to support one purpose: massive computational workloads. Inside these facilities, thousands of servers are stacked into rows of metal racks. Each rack contains powerful processors, high-speed networking equipment, and advanced cooling systems. These machines work together as part of a massive computing cluster. Instead of a single computer performing a task, thousands of processors cooperate. Each processor handles a small piece of a larger problem. When combined, they form a computational engine capable of extraordinary performance. The processors that power these clusters are not typical computer chips. Many of them are GPUs, graphics processing units. Originally designed for video games, GPUs are built for parallel computation. Instead of performing one calculation at a time, they perform thousands simultaneously. This makes them ideal for artificial intelligence workloads. Training a neural network involves processing enormous matrices of numbers. These operations must be repeated millions or even billions of times. GPUs excel at this type of work. Over the past decade, GPUs have become the backbone of AI computing. Companies like NVIDIA have designed specialized chips capable of accelerating machine learning workloads. These chips now power some of the most advanced AI systems on Earth. Inside large AI data centers, thousands of GPUs operate together in coordinated clusters. These clusters require enormous electrical power. A single large AI facility may consume as much electricity as a small city. Power distribution systems must be carefully engineered to supply stable energy to every rack. But electricity is only part of the challenge. These machines generate enormous heat. If that heat is not removed efficiently, the hardware can fail. To solve this problem, data centers use advanced cooling technologies. Cold air is circulated through server racks. Some facilities use liquid cooling systems that transfer heat directly away from processors. Others experiment with immersion cooling, where servers are submerged in specialized fluids. Cooling is one of the largest operational costs for modern data centers. But the infrastructure challenges do not stop there. Networking is equally critical. AI training clusters require extremely fast communication between machines. Thousands of GPUs must exchange data continuously. If network connections are too slow, the entire system becomes inefficient. To solve this, modern AI data centers use specialized high-speed networking technologies. Fiber optic cables connect servers across racks. Advanced switches manage data traffic between processors. These networks operate at extraordinary speeds, often hundreds of gigabits per second. All of this infrastructure exists for a single reason: training artificial intelligence models. Modern AI systems require enormous datasets: image, text, audio, video. During training, neural networks analyze these datasets to learn patterns. This process requires repeated calculations across massive amounts of information. Some AI models require weeks of continuous training on clusters containing thousands of GPUs. These training runs consume extraordinary computational resources, but they enable machines to develop remarkable capabilities. Language models can generate human-like text. Computer vision systems can identify objects in images. Recommendation systems can predict user behavior. All of these capabilities depend on data center infrastructure. Without these facilities, modern AI would not exist. But building these centers is extremely expensive. Constructing a large data center can cost hundreds of millions of dollars. Some hyperscale facilities cost billions. Technology companies invest enormous resources into expanding their AI infrastructure. Companies like Google, Microsoft, Amazon, and Meta operate some of the largest data centers in the world. These facilities are sometimes referred to as hyperscale data centers. They are designed to scale computational resources to extraordinary levels. Hyperscale infrastructure allows companies to deploy thousands of servers quickly. When new AI models require more computing power, additional hardware can be added to the cluster. This scalability is essential for modern artificial intelligence research. But location also matters. Data centers must be built where electricity is reliable and affordable. Many are located near hydroelectric power sources. Others are built in colder climates where natural cooling can reduce energy costs. Some facilities are placed near major fiber optic networks to ensure fast connectivity. Geography plays an important role in the global distribution of AI infrastructure. As artificial intelligence becomes more important, countries are beginning to view data centers as strategic assets. Control over AI infrastructure may influence economic and technological leadership. This has triggered massive investments around the world. Governments and corporations are building new facilities to support the next generation of AI systems. The scale of these projects is astonishing. Some AI clusters now contain tens of thousands of GPUs. These machines represent some of the most powerful computing systems ever built. But the demand for AI computing continues to grow. New AI models require more data, more parameters, more computation. This creates a feedback loop. More powerful hardware enables more advanced AI models. More advanced AI models require even more hardware. As a result, the global race to build AI infrastructure is accelerating. Technology companies are competing to deploy larger and more efficient data centers. Chip manufacturers are designing processors specifically optimized for machine learning. Networking companies are developing faster communication technologies. Cooling systems are evolving to handle increasing thermal loads. Every part of the infrastructure is being redesigned for artificial intelligence. The AI revolution may appear to be about algorithms, but the real foundation of AI is physical infrastructure. Buildings filled with servers, miles of fiber optic cables, massive electrical systems, and thousands of processors performing trillions of calculations every second. When people ask where artificial intelligence lives, the answer is not the cloud. It lives in data centers, hidden behind secure doors, operating continuously, powering the intelligence of machines. As artificial intelligence continues to advance, these facilities will become even more important. New generations of AI models will demand even greater computational power, and the infrastructure supporting those systems will continue to expand. The AI revolution is not just a software story. It is also an infrastructure story, a story of engineering, electricity, and silicon. And inside the world's largest data centers, the machines that power artificial intelligence are already running.